let me start by introducing myself. Like Deepti mentioned, I'm a product manager in Azure AI. I work on a service called Form Recognizer, and Form Recognizer is really about extracting information from documents. That's our core competency, and today what I would like to walk you through is a number of different capabilities we have within Form Recognizer in terms of how you get the most out of the product, and specifically around unstructured documents. But before we get started, let me give you a quick overview of what Form Recognizer really is, right? So if you think about the capabilities that exist within Form Recognizer today, it's about taking in documents as input and generating an output that represents the information that you'd like to extract from each of these documents. There's a number of different use cases and a number of different scenarios, and as a result, we have a few different APIs that allow you to work with Form Recognizer. The best analogy that I have to describe this is something like a wedding layer cake. The bottom layer of that wedding layer cake is the read API, which is really about extracting text from documents, right? So at the most basic form, what Form Recognizer does is it allows you to take in a document and extract all of the text that you can extract out of that document. The next level up from there is being able to extract not just the text, but also some amount of the structure contained within each of these documents, and that's the layout API. What the layout API allows you to do is extract not just the text, but structure as well. We also have a pre-built document API, which is targeted to extract key value pairs from each of these documents. And as you go through this process, you'll see that the outputs of each of these APIs is somewhat additive. So when you call the layout API, for example, you get the output from read as well as layout. When you call the document API as an example, you get the output from read, layout, and document. And what document does is it specifically extracts key value pairs from a document as well as entities. And we're going to go through this in a little bit more detail as we go along. And we also have a few pre-built APIs, and the pre-built APIs are for pre-built models, right? And so these are specifically for scenarios where you want a high degree of fidelity, both in terms of the taxonomy that you want to use, as well as the accuracy on extracting the right content for each of those specific fields within that taxonomy. And the pre-built APIs we have a number of different pre-built APIs ranging from invoices, receipts, IDs, health insurance cards, and so on. And so those are for common workflows, common scenarios that you see a lot of, like for example, procurement uses a lot of invoices, and you really need a targeted model that can do well with those specific types of documents. And finally, for scenarios where you have documents that may not necessarily fit a pre-built model, but you still want to extract specific text or specific content from these documents, the custom model is where you would want to go off and build your own custom model. And again, as we go through this unstructured document workflow, I will be spending a lot of my time in the custom models anyway, so you're going to get a lot better sort of understanding of what capabilities exist as we look at each of these different types of models, right? So we talked a little bit about what each of these different types of models extract, and the key sort of call outs here is as you look at custom models, you'll notice that it's now broken out into template models and neural models. And I'll talk a little bit more about what these differences are and how you want to use or what scenarios you want to use each of these different types of models in as you try to build your applications on the outputs that Form Recognizer provides. Just as a quick overview in terms of where we are today, I just wanted to call out that we did make a few different changes to our product. There's a new pricing model in place now where our price is significantly lower in terms of some of the pre-built models that you can use. And so I'd encourage you to go look at the Form Recognizer documentation page and just go see what the latest updates are. We dropped our price for invoices as an example, as well as the pre-built document from $50 for 1,000 pages down to $10 for 1,000 pages. So that's a significant amount of value. And so we expect that this is really going to help you sort of consider Form Recognizer in your sort of high throughput use cases. We also have a few updated or new pre-built models, and you'll see that we've now updated the invoice model for Spanish languages, and we're continuing to improve our language coverage and pre-builds. But we also have a few new models like the W-2 model or the health insurance card model. And finally, we're continuing to update sort of the capabilities that are available within each of our different models and different APIs, like for example, checkboxes with general document model. There's a new unstructured document model for using custom neural models, which is sort of like the core of this presentation today, and we'll talk about that in a minute as we go along. The core flow of what you go through within Form Recognizer is you submit a document in for an analysis. It goes through a number of different sort of processing pipelines that we have, and we generate an output that is a JSON output. And excuse me, this allows you to use this particular JSON output in any of the different scenarios that you have in terms of integrating it within your application workflows. Let's go take a quick look in the Form Recognizer Studio, which is essentially the where you go build your models as well as where you go test your models. So let's take a quick look at the Form Recognizer Studio, and let's understand how some of these capabilities sort of apply to the scenarios we've just described. So I'm going to switch my screen over to the studio, and what you'll see is here I'm in the Form Recognizer Studio. To get started with the studio, all you need to do is just configure it to use a particular Form Recognizer resource. So you'd go into the Azure portal, create a new Form Recognizer resource, use the endpoint and the key from there to go ahead and configure your Form Recognizer Studio to use that particular resource, and now you're off and ready to get started. So let's take a quick look at each of the different APIs that we just talked about, right? So for example, let's start with the read, or let's start with the layout API, because the read API is obviously sort of a subset of the layout API. So once you go through the layout API, you'll see the output from read as well. So the first thing you'll notice is I have a few documents in here that I can analyze, but I could also add a document that I wanted to analyze if I were to choose a specific document that I wanted to try this out on. The output from the layout API, you'll notice, is obviously all of the text that was extracted from this document, but it also contains a few different additional elements, right? So if I turn off the text, you'll see that this little yellow hue or yellow highlighting behind the text goes away. And so this is sort of an indication to you in terms of like what text was actually recognized by the model. We also have a few tables, right? So what I'm going to do is I'm going to turn off each of these things and just focus primarily on the tables. And you'll notice that I actually have two tables that were identified as part of this document. Notice that tables are extracted by default. This is an unsupervised model. All it's doing is looking for information that it thinks is represented as a table, and it's extracting that as a table. So if I clicked on this little table icon, I can visualize the output that the model is generating now to say these are the different columns or table or rows that were extracted from each of these from this particular table. And I can similarly do that for the additional table as well that was identified on this particular page. The next thing I can also do is I can turn off table selection and just turn on the selection mark box, right? And here you'll see that it's identified a couple of different selection marks that are checkboxes that are available for you to use. And it's telling you what the state is for each of these. So in this case, it's identified that there are these two selection marks and the states are unselected on both. So if you look at the result in JSON, you'll see that there's a number of different elements to it, right? So the first output is the pages, which is essentially the output from OCR. The next output is things that the layout model is generating, which is tables as well as styles. So this is essentially how you use the Form Recognizer layout API to just extract structure. The layout API is being updated right now, and there is an update planned for June, where you will see not just tables as well as selection marks, but we're going to be extracting additional page object details, things like headers, footers, like paragraphs, as well as section titles, section body, and so forth, right? So it'll allow you to better decompose a document and target specific areas of a document for analysis, right? So for example, if you wanted to run an NLP model through just the executive summary of a specific document, you could now go find the executive summary section of a document, extract just that text, and run your NLP model that you may want to run on that specific aspect of that document. So a common scenario or common use case, for example, would be where you want to run the text analytics for health model, but you want to run it only on the doctor's notes section of a document. And so you would want to run that text analytics for health, which is in an Azure language model, on just the text extracted from the doctor's notes or the doctor's summary. So that's the layout model. I can also show you the general document model really quick. Again, the general document model is similar to the layout model, but in addition to all of the things that the layout model extracts, it does a few additional things, right? The core capability here is it is able to extract not only the table selection marks and so forth, but it also can extract key value pairs from a document. So if you notice here, it's extracting both the selection mark as well as the associated key or associated value with that selection mark. And similarly, it's extracting some key value pairs here, right? So a good example of that might be something like this, which is essentially what is the IRS ID, and the value is this 91 number. So that's an example of how we're able to extract key value pairs from a document that then allow you to not just work with the extracted text, but identify what are the specific elements within this document that you're most interested in. The key value pair extraction works not just for documents like this, but also documents like this where you have each of these elements in a box, and it's able to extract not just the key, but also the value from each of these documents. The other thing that I'll call out is the general document API also produces entities. And so these entities help you understand what the context is that each of these different keys or values are being used in, right? So for example, you might go look at a particular value and you can see like what is the type of entity that is, and it's like in this case Microsoft Corporation, and it may be an organization, right? So in this case we're extracting all of these entities that you can then use in your downstream sort of data validation workflows in terms of extracted value as well as the type of entity to make sure that you've got the right value from each of these documents. So that's some of the capabilities from the layout model and the general document model in a nutshell. I'll focus a little bit on the pre-built models now before we jump into the core content that we wanted to talk about, which is extracting text from unstructured document, or extracting key value pairs from unstructured documents. Really quick, invoice models also exactly similar to what we just talked about with the layout model, for example. In this case, the only key difference is the taxonomy of the fields that is extracted. You'll find that each of these fields, irrespective of how they're described within the document, maps to a specific taxonomy for the invoice model. The other key thing that I'll call out is the output of this document. For example, you'll see the similar things that you saw with layout. You'll see pages, you'll see tables, but you'll also see documents in here. And in this example, the document type we've analyzed is an invoice, and you'll see that all of the invoice values are really part of this fields property within the output. So fields is a dictionary, and that dictionary contains each of the different sort of key value pairs that were extracted. So for example, the amount due is of type currency, and the value is $610. So that's essentially how you interpret the output that each of these models generate. With that, let's pop back over to the slides really quick, and then let's look at maybe a couple of things as we talk through how we extract text or key value pairs from unstructured documents. When Form Recognizer started off, we were really good at extracting text or extracting content from highly structured documents, right? And what we also recognize is there is a latent need in every organization today to deal with semi-structured as well as unstructured documents. And you'll see that when we started off with a single model that was really called the custom form model, or the template model. And the template model is really good at extracting text from or key value pairs from a document that looks like sort of the left half of the screen, right? So it's highly structured documents. But then there's a lot of documents that organizations deal with today, which are highly unstructured, right? So think about these as, for example, these deeds of trust, contracts. There's a number of different types of documents that are unstructured, but you still need to extract all of the different pieces of information that help you process these documents better, or help your business processes sort of align around these documents. And in order to do that, we have a new model architecture now called the neural model architecture. And the neural model architecture is different from the Form Recognizer sort of template model, in the sense that it uses both layout signals as well as language signals, and fuses those two options, or fuses those two features to now build a model that is better at extracting both key value pairs from structured documents as well as unstructured documents. So it spans the gamut of structured as well as unstructured, whereas the template model is really focused on highly structured or somewhat structured documents. So let's go take a look at what the process is for you to go build a model that can do some of these things, right? The one thing that we've tried to do as we go through this sort of transformation within the product is ensuring that we have sort of continuity and stability within our sort of how you build and sort of manage these models, right? So you'll notice, the first thing you'll notice is the structure of how these models are generated is identical, in terms of saying that what we do is we have the exact same labeling schema, exact same labeling format for either of those two model types, and choosing which model you choose to train is really a question of just changing a single drop down that allows you to then target either the template model or a neural model. So in terms of what you need to do to get started, you only need 5 sample documents to get started. So you start with 5 sample documents. You add those 5 sample documents to a storage account. Once you have them in a storage account, you can then go through a labeling experience within the Form Recognizer Studio, and I'll show you what that experience is in a minute. Then you need to think about how you're dealing with variability, right? So, and when we talk about variability, we're talking about things like, document structures being different, right? So, for example, with the template model is highly sort of tuned to a model or highly tuned to a specific template. And so, for example, if you go from, like, say, a W2 from 2020 to a W2 from 2022, there is going to be some differences, or W2 provided by one payroll provider versus a different payroll provider. There is going to be some differences in terms of like where things are laid out, where, field 1 or where field 17 is, and so forth. So there's going to be some variations that you're going to have to deal with. And as you think about that, you'll have to think about which model architecture you're using, because the answers for each of those is different, in the sense that the template model will require you to train a single model for each of those variations, and then you can compose those models together into a single endpoint. And when you analyze a document with a composed model, the system then determines which of the underlying models is best suited to deal with that particular document, and invokes that model to analyze that particular document. But you don't need to do this with a neural model, and I'll show you a little bit more about like how you train a neural model in a second here. The last step in this process is essentially training your model, and then you go through the process of validating confidence scores and then testing the model. So let's go take a look at what this whole process looks like end to end in the studio, right? So let's go back into the studio, and this time I'm going to skip down past all of the different pre-built models down to this custom model section. I do have a few custom models trained, and so let me walk you through a couple of different things before we dive into the actual process, right? So the first thing you'll notice is I have a project right here for a W9 form, and this is again a highly structured form. So the way I've labeled this document, I've labeled it to now say that I'm extracting all of these different fields, right? And I'll show you what the labeling experience looks like in a second here. So essentially, I have a few different documents. If you look at the studio, you'll see that all of the documents that I have in my storage account are aligned on my left. And each of these documents, if I can click through that, it shows up in here. And then I can scroll through each of the pages using the chevrons at the bottom. So in this particular document, I have all of the fields that I'm interested in labeled. You'll see that each of these is highlighted using a specific color, and the associated values that I've labeled is also in here, right? So as a quick example, let me maybe like remove some of these values, and then let's take a look at what that experience might look like in order to do that, right? So the first thing you'll notice is I'm in this document. I need to maybe label the name. And all I need to do is go select the text in here and pick the associated label that I want to use for each of those, the field name that is associated with that value. Similarly, in terms of dealing with signature here, so I'm just going to go ahead select a region, because that's essentially where I expect the signature to show up. And once I have that region selected, I can go ahead and then annotate that to say this is the signature region that I want to use. You also have the ability to define tables, and I'll show you that in a second as well with a different form type, right? So I'm going to go back into my custom models. I'm going to pick a completely different form. I'm going to pick a sample document that looks something like this. And here I now have obviously the data that is extracted as a table out of layout, but I also might want to use something really specific to what I'm trying to do and extract only maybe a subset of this, or extract a slightly different schema that I want in terms of the output that I want from my custom model. And in order to do that, I can now define a table, right? So you can see I've got a maintenance log table here. It's as simple as going ahead and defining a new table, setting that as a dynamic or a fixed table. A dynamic table is where you want where you don't know how many rows are going to show up in the document. You just know that it's going to be a tabular format, but you don't really know if there's going to be 1 row or 15. And that's where you use a dynamic table. If you know that it's always going to be a 3 by 3 and there's nothing more that I expect to find here, then you could set that up as a fixed table and with a sort of a 3x3 grid that allows you to extract each of the values within those cells into your table. So once I go ahead and create this new table, I can then, labeling a table is again extremely simple. I select the text that I want and then click on the cell that I want to assign that to, and that's essentially the way I label a table, right? So now I've got a table labeled out here to say these are the values that are contained within each of the cells of this particular table. And at this point, I have all of my documents. I needed to have at least 5 documents, which I do. And with these 5 documents labeled, I can go ahead and hit train. And when I train a model, I just need to give it a model ID here. In this case, I'm going to give it a model ID that says, like whatever, maybe car maintenance model. And once I have this car maintenance model, I'll just call it the ODSC model. And once I have this model selected, all I do here is select whether I'm trying to train a template model or a neural model or a template model. In this case, since it's a form that works really well with highly structured documents, I'm just going to go ahead and select template. I hit train, and you'll see that the model is going to get trained, and it takes maybe a minute or two to train this model. So once I go back in here, you'll see that this ODSC model is being trained. This probably will take about a minute. While this is doing that, let's go back, look at the core sort of question that we were asking as we started this whole conversation. And in order to do this with unstructured documents, I'm going to use a data set that is, it's publicly available. It's a QAD data set for contracts. And I've essentially taken a few documents from there. So I'm only using this data set to train this model. I'm only using this data set to test this model. It's just a sample or a demo that uses that data set. It's publicly available on the internet. I can paste a link to it in the chat if you're interested to try this out. And what we're doing here is I've selected a subset of documents from within that QAD data set, and I've added this into a project that I'm using now. So you'll see that each of these documents, there's about 63 pages in this particular document. For example, each of these documents has a highly varying structure. They're all different documents as they deal with the different elements of a contract. In this case, I think it's a development contract. So all of these documents are really focused around some of the way the data set is laid out. This is this subset of documents is development contracts. You'll notice that there's really no sort of repeating structure across each of these documents. They're all varying structure. And what I'm trying to identify here is, in this particular example, all I'm trying to do is identify who are the different parties involved. So I've got a party one, a party one alias as well, right? So you'll notice that in each of these documents, there's also going to be a, like as you look through the text, you'll notice that there's some, ways that things are described where it says, so-and-so referred to as the fund and so-and-so referred to as whatever the blockchain administrator or something like that, right? So I'm interested in what that alias is that they're being sort of referred to in the rest of the document as. And in order to do that, I'm sort of extracting both the party name as well as the party name alias. Similarly, there's the party 2 and the party 2 alias. Finally, I'm also looking for the agreement date. And if the document contains an address for each of these entities, I want to extract those as well. And the other thing that I'm trying to do is I'm also looking for like a force majeure clause, right? So this is a way for us to describe some of the capabilities of the model to not just extract key value pairs, but also extract clauses to say, does this document contain a force majeure clause, as an example. And so one of the things that I'm doing here is I've labeled this force majeure clause in here. You'll see that it's, I guess it's somewhere down on page 17 or so, but we'll look at it as we go along. The other thing that I'm trying to do is I'm trying to look for like things like a notice period, right? Is there a contract notice period that exists where, the two parties have to agree on, like, say, maybe 2 weeks or 5 weeks or something as a notice period to terminate this contract? And finally, I'm looking for confidentiality clause, as well as what are the payment terms that the two parties are agreeing to. So all I need to do in order to do this is essentially go through this process, label each of these documents with the exact same process that we described as we were looking at training a template model, And once I have these models built out, I can then go ahead and hit the train button here. Once I have all the labels built out, I go ahead and hit train. I can give it a model name. And in this case, instead of selecting the template model, I'm just going to select the neural model, and I can hit train, right? So that's essentially the process of training a neural model. So this model is essentially going to take about 20 to 30 minutes to train. So rather than try to do this right now, what I've already done is I've gone ahead and trained one using this exact same labeled data set. And so let's go look at some of the outputs that this model can work with, right? So in this particular instance, you'll see that our car main sort of ODSC model trained successfully, because that's a template model that takes only about a minute or two to train. So it was completed, and it completed successfully. And I can try it out now. So I can always select this model and hit test and test this out. But rather than do that, we're going to train. We're going to test out the QAD model that I built earlier. So in this case, I'm going to pick that QAD model, which is which one? I believe it was this one. So we can try this one. And the first thing I'll do is I'm going to go ahead and add a document to this that the model hasn't seen before, right? So in this case, I'm going to pick a data set, a folder that contains my test documents. And this is an example of a document that the model hasn't seen before. And I can go ahead and click Analyze. And so once I click Analyze, it's essentially submitting this document to the model for analysis, going through the exact same process on all the 23 pages of this document to extract all of the things that we talked about from read APIs output, layout output, as well as the custom model output, right? So, and in this case, the custom model output is going to be all of the things that we were looking for, which was essentially the party one, party two, and all the different clauses that we were looking for. So this takes a couple of seconds to run, and once the output's ready, we can actually validate or visualize the output using the studio as well. Once your model is built out and you have it configured to do all the things that you want, you can then go ahead and use it using the REST APIs or the SDKs or any of the other tools that Azure provides to invoke these models, right? So, for example, you could wrap it up in a function app, or you could wrap it in a web application. However you want to use it, it's all available for you to use. So let's look at the outputs that we were able to generate, right? So the first thing we'll see is I'm just going to scroll in a little bit and expand this so it's sort of more obvious or easier to see. The first thing you'll notice is the agreement date. It extracted that as June 12th, which is exactly what we were looking for. It also extracted each of the different participants. In this case, it says Eton Pharmaceuticals. The alias for that is Eton, and the party two is whatever Akuta Pharmaceuticals, and it extracted the right alias for that as well. And then finally, you'll notice that the party one address, for example, is extracted here. The one thing that I'll call out is the party one address. While it extracted the correct value, the bounding box may not look exactly right, and that's only because we're using sort of the X and Y coordinates to draw the bounding boxes, and it's a value that's spanning across two different lines, and as a result, you'll see the bounding boxes sort of like the min X and the max X and the min X and the max Y sort of driving this bounding box to be a lot bigger than it needs to be. But the actual value extracted is exactly what I need. Similarly, for the party two address, it's extracting that from the right place as well. And then let's go look at like the force majeure clause, for example, right? So the force majeure clause is on page 19, and you'll see that it's described in here using the text that it extracted as the force majeure clause, right? So this gives you an idea of like how you can use the custom neural models to not just extract key value pairs, but also identify the presence or absence of a particular clause. So notice period, again, you'll notice that it's 30 days, and it's extracting that from the fact that it's able to extract that out of this particular span of text, and it's on page 13 of 23. And similarly, the confidentiality clause, if you look at that, that's extracted from this particular clause on page 11, and it's extracting the exact text that we wanted to be able to represent what is the confidentiality clause within this particular document. And finally, if you look for the initial payment amount, the initial payment amount is on, I guess it's on page 7, and the value is amount of $2 million within 5 days of the effective date of the agreement. So that's the initial payment amount that's being described within this document. So this was essentially a quick example of how you go about training a model that extracts not only key value pairs, but also any structured information, as well as things like clauses from a specific document that is highly unstructured. You don't have any sort of control over how the document is authored or how the document is created, but the model is still able to extract the fields that you need based on being shown just in this example. I gave it maybe 7 or 10 examples or 7 or 10 labeled samples to train with. But that's essentially all this model needs in order to refine itself or to fine tune itself on to the task that you're trying to train it for. So let's pop back over to the slides, and I will sort of wrap things up by sort of like maybe describing some of the differences between the two model types, right? So as you look at the template model as well as the neural model, you'll notice that there's a few different differences, right? So for example, template models work really well with highly structured documents, highly structured forms. Neural models work well with both the structured, semi-structured, as well as unstructured documents, right? So they work across the gamut of different document types. As a result, they take a little bit longer to train. They take about 30 minutes to train, or 20 to 30 minutes to train. The template model will typically train within 1 or 5 minutes, right? So that's a really quick model to train. The other thing you'll notice is there's not quite feature parity between these two models. We're working towards that. For example, today, key value pairs, tables, selection marks, signatures, regions, these are all features that you can use within a template model. That's somewhat constrained within a neural model. We're working on an update in the next month or so. You'll see that we're going to be supporting tables. So key value pairs, selection marks, and very soon tables are the other supported sort of features that you can use within a neural model. Similarly, in terms of how you deal with variations, in terms of template model, you create a model per variation, and then you compose those different variations together into a single model. So essentially, you're training one model for each of the different variation types and then composing them all together. Whereas with the neural model, you don't need to do that. You essentially just add more training samples into your training data set. You train your model with all the different variations, and your model learns from the training data set of the different variations and how the different values are represented in each of these documents to then extract the right values from a document that it sees as part of the inference pipeline. And finally, in language support, all of the 160 plus languages supported within Form Recognizer are now supported within template models, whereas the neural models are currently English only. We plan to extend that to include other languages as well. But as of right now, that neural model really works well with English documents only. The last thing that I'll call out is we do generate an accuracy score during training, whereas for the template models, but for the neural models, you have to actually provide an additional data set that is a validation data set that you would use to generate a accuracy score after the model has been trained. So this requires, in addition to the 5 or so labeled documents, you would need to provide an additional small labeled data set, maybe another 5 or 10 labeled documents to now generate a validation score on the model or the accuracy of the model that you just trained. So with that, I've sort of reached the end of what I wanted to cover in terms of content, in terms of how you use a Form Recognizer custom neural model to extract key value pairs as well as structured information like clauses from a unstructured document. If there's any questions, I'm happy to take them as we go forward here.